Question number 7 deals with what? Yes, question number 7 deals with what? Methods of getting a polarized light. So what is given is unpolarized light. What is given is unpolarized light. And you want to change it to polarized light. So there are 3 methods given. Method number 1 is what? By reflection. You get a numerical part on this part. So method 1 is polarization by reflection. Second method is by scattering. Polarization by scattering. Third is by refraction. There are 3 methods. You have numericals primarily on part 1. Method is, you have a reflecting plane. Say a glass slab like this, and this material has a refractive index nu. In this case it is glass. So this is normal to the surface, and you get one ray, incident ray, hitting this at angle of incidence I. This ray is unpolarized light. How you represent unpolarized light? This part shows oscillations towards the reader like this, red color. This blue color represents oscillation along this. So this is a method to represent what light? Unpolarized light. So incident light is unpolarized. You get light transmitted to the other. If it is air, this is glass. When light travels from air to glass, from rarer to denser medium, it bends towards. Suppose this angle of refraction is R. What about reflected ray? Yes, the reflected ray angle of incidence is equal to angle of reflection, law of reflection. Now this ray is partially polarized when you keep on changing this angle. For say 60 degree, 45, 30, you keep on changing this angle, this ray is partially polarized. For one condition, this ray is completely polarized, and the oscillations of this, as seen by you, it is perpendicular to this board, perpendicular to this plane. Only these oscillations are available. So this is polarized light when this angle is equal to 90 degree. So if this condition is satisfied, then this light is polarized. Repeat. This is unpolarized light. After getting reflected, it can be polarized if this condition is satisfied. If this angle is 90 degree, this is polarized. These oscillations are perpendicular to this plane. This is known as plane of incident. Incident ray, normal to the plane, reflected ray. All these lie in plane. This is the plane. Board plane is plane of incidence. These oscillations are perpendicular to plane of incidence. Objective question. That refracted light is polarized, but it is polarized with its oscillation parallel or perpendicular. Answer is perpendicular. So reflected light is polarized. What about this one? This light, this one is partially polarized, refracted. It has both oscillations. It may have 10% polarization, 20% polarization, whatever that is. In this, at present, in method number 1, we are not to study this one. We have to study only this part. So what is the condition? Condition. The reflected light is completely polarized if reflected and refracted rays are perpendicular to each other. This total angle is equal to what? This total angle, I plus 90 plus R. I plus R plus 90 degree is equal to 180 degree. So this angle I will write it like this only. I plus R is equal to what? 90 degree. This is 1. Time with you is 3 minutes to write. 1 full page is required. 3 minutes to write. This is equation number 1. Is there any relationship between I and R? Anyone? Angle of incidence and angle of refraction. Is there any relationship? Yes. 1. This material has a refractive index 1. This material has a refractive index equal to nu. 1 into sine I. 1 means nu 1 into sine of angle is equal to nu 2 into sine of angle. Nu 2 is equal to what? Nu sine R. Law of refraction. 1 into sine I, covered in school. Nu 1 sine theta 1 is equal to nu 2 sine theta 2. So this material is, in this case, air, free space, 1 into sine I is equal to nu times sine R. From, this is equation number 2. From 1 and 2, you can write the whole expression in terms of I. How? Sine R. R is equal to what? 90 minus I is equal to what? Nu sine 90 minus I is what? Cos I. So sine I is equal to this. Sine I by cos I is what? Tangent I is equal to nu. Or I is equal to tangent inverse nu. Means what? If nu of the other material is, say, root 3. Suppose nu is root 3. Tangent theta is equal to root 3 means theta is equal to what? 60 degree. So if you know the second material, that means if you know the refractive index of glass, in this case, from air to glass, if you know nu of glass, then you know angle of incidence. Now nu is different for violet, indigo, blue, green, yellow, orange. So this I is also different for different. That is why it is true for particular nu means what? Monochromatic. Because for other wavelengths nu will be different. So I will be different. So this is polarization by reflection is achievable for monochromatic light. Time with you is 2 minutes to write. What is the conclusion? Yes. Tangent I is equal to nu. What was the condition? Yes. I plus R is equal to 90 degree. So this is the takeaway, conclusion from the article. Now we refer to the numerical part. Numerical number 20. Question is, when sunlight is incident at an angle of 53 degree on the surface of water, the reflected light is plane polarized. Calculate the angle of refraction and refractive index of water. Given is what? Angle of incidence. I is equal to how much? 53. Find. You have to find out what? Angle of refraction R and refractive index. 2 minutes with you. Try. How to find R? Yes. The reflected light is polarized when I plus R is equal to 90 degree. I is given as 53 degree plus R is equal to 90 degree. Means what? R is equal to what? 90 minus 53. Yes? 1. 2. You have to find out what? Nu. Condition is tangent I is equal to nu. Nu is equal to what? Nu is equal to tangent I. What is the angle of incidence? 53 degree. Tangent 53 degree is equal to. Yes. Now you will have to refer to the table. Tangent 45 is what? 1. Tangent 45 is 1. Tangent 60 is root 3. Root 3, 1.7. So this value, the only thing you can say without table is the value lies between 1 and 1.7. Exact, if you refer to the table, then you can come out with the answer. Here this value comes out to be how much? Yes, 1.327, approximately 1.33. Nu is 1.33. Refer to numerical number 17, 17. Write what is given. Numerical number 17 is, a ray of light falls on a transparent glass slab of refractive index 1.62. If the reflected ray and refracted ray are mutually perpendicular, what is the angle of refraction? Given is what? How much? 1 point? You have to find out what? Yes. Angle of refraction, that is this angle R. Refraction. R you have to find out. If nu is given, step 1. Tangent I is equal to nu. It is 1.62. Tangent I is 1.62. I is equal to what? This is 1. Step 2. If I is known, you want to find out what? R. I plus R is equal to what? 90 degree. R is equal to what? 90 minus I. That means, if you know the value of I, if tangent I is equal to 1.62, we need to find from the table, approximate I will answer. It is 90 minus 32, 58. This value 58. Tangent 60 is what? Root 3, 1.7. It is 58. You will have to get it from the table, no other way. Once you find I is equal to approximately 50, it is 90 degree minus 58 degree comes out to be what? Yes, 32 degree. Approximate answer is 32. This was method 1 of knowing how I is connected with the R. Yes, this angle reflected ray and refracted ray, angle between the two. Whenever this angle is 90 degree, this ray, reflected ray, will be polarized. Relationship between I and R is I plus R is equal to 90, and from the derivation, conclusion was tangent I is equal to refractive index nu. This is method 1. Method 2. Method 2 is by scattering. Method number 2. One minute to go through. Polarization by scattering. 1 minute to go through. A cloud, space, some material with particles comparable to wavelength of light. Dust, very fine dust particles comparable to wavelength of light. Light is coming from which direction? Question number 1. From x-axis. What type of light it is available? Unpolarized light. How you represent unpolarized light? This is oscillation towards you, towards the reader. This is oscillation again towards the reader. And this is oscillation perpendicular. So, this is the phenomena. Particles, fine dust particles, having size comparable to wavelength of light. So, unpolarized light hits. These particles absorb this radiation and re-radiate. They re-radiate in all directions. But suppose the observer is along y-axis or along this z-axis, but I need to mark on the board. So here I can explain that this is z-axis and observer is here, but on board I need to mark it like this. So this is y-axis, this is z-axis. So these oscillations, if there is I here, or you can say I at this point, one observer I here, it will have these oscillations, red oscillations perpendicular to this plane. Blue oscillations are into the eye. Agreed or not? Like this. This is the eye. These blue oscillations are into the eye. So that is why blue in this case is not visible. For this candidate, it is a red oscillation which is available and to be marked like this. And the light is polarized. What about this one? If there is an observer here, I is placed at this point. This is z-axis. This is the location of I, and these blue color oscillations are available. Am I right? Because they are perpendicular. That is why you can mark it like this. What I want to convey is that if there is unpolarized light hitting this cloud of what particle? comparable to wavelength of light. They absorb and re-radiate. These observers, those are perpendicular to this axis. That means in which plane? YZ plane. These observer will find the light to be, yes, polarized. This light is also polarized. So, phenomena for scattering is that small particles absorb and re-radiate light. Incident light is of what type? Yes, incident light is unpolarized. It is along which axis? X-axis. Then scattered light is polarized along, in this diagram, y-axis and say z-axis, or any direction which is perpendicular to x-axis. 2 marks question. 3 minutes with you to write. 3 minutes to write. Method 3. Method 3 is polarization by refraction. Arrangement is same. A glass plate, light hits at angle of incidence, angle of polarization. That is, the phenomena is same as that of experiment number 1, method number 1. One glass slab, a ray of light. Which one? Unpolarized. Unpolarized light means what? It will have oscillations perpendicular to the plane. Parallel to the plane. This light is what type of light? Unpolarized light. It hits at what angle? Angle of incidence, such that this reflected ray and refracted ray are normal to each other. Then reflected ray, this ray, was having oscillations perpendicular to the plane, perpendicular to this board. This light was polarized. What about this light? Refracted. This refracted light is partially polarized. Means what? This is 100% polarized, this is partially polarized. Suppose this red part is less, you can have blue color like this. Then pass it through another glass slab, place one more slab. When you place it, again this passes through second, third, fourth, keep on placing number of such slabs, and what you observe is, when this ray on the other side comes out, it has oscillations only in the plane. So means what? This light is also polarized. This is polarized. This one is also polarized. Difference is what? Direction. These oscillations are perpendicular to plane. and these are in the plane. So, means what? Polarization by refraction is what? Polarized light is by placing, yes, polarized light is obtained by, you can say, polarized light is obtained by placing number of plates in order. Plate number 1, plate number 2, plate number 3, number of plates you will have to place, because each plate, first suppose make it 90%, then 95%, then 98%. So you will have to place number of plates to increase the percentage of polarization. 2 minutes with you to write.